Now let's see the register mode. So what is register mode is, we'll be given the operand in the register, and in the instruction we just put the register number. For example, you might see something like this: add R1. If this is the instruction and if it is given that we are using this register mode, then what is the meaning of this one is, in order to get the operand, you need not use any address. You just go to the register and find the operand there. That is the meaning of it, right? So in other words, I'm just assuming that we are having that accumulator type of organization. Then what we do is, we take the contents of the accumulator and the contents of the register R1, and then we place the result in the accumulator. This is the meaning of this instruction, provided that the mode is register mode. Got it? So what is the advantage of this mode? We are not dealing with any addresses here. We are just giving the register number. That's it. So the instruction is going to be very short. In case if you have, let's say, 16 registers, in order to supply one of the register as the input or the operand in the instruction, we just need 4 bits instead of having a long address. Sometimes if it is a 1 kilobyte memory, then it is going to take 10 bits, right, for the address, but here it is short. Therefore the advantage is, instructions are going to be short because only register numbers are mentioned there, and the other advantage is, execution is fast because you need not go to the memory to fetch it. But then in order for this instruction to happen, prior to this instruction you are supposed to load this particular register R1 with the required operand. Either you load it explicitly by using the load command, or this could be, R1 could contain the result of some other instruction which is going to be used as the input here. Got it? So whatever it is your responsibility to see that the operand is present in the register. So what are the kinds of questions that will be possible here is, one type of question is, they will say that there are n number of registers. Then how many bits are used or required in order to specify an operand here in the register mode? Then how many bits are required? Log n base 2, isn't it? Seal. And the other question is, they'll say that the size of the register is n bits, size of the register. Then if the operand is specified in 2's complement number system, then what is the maximum size of the, or what is the maximum magnitude of the operand possible? Then in that case, in 2's complement, we already know that, what is it, 2 power n minus 1 minus 1, this is the maximum, or they might ask you minimum. You can work it out, we have already seen it, right? This is one more type of question possible. Or they will give you that the instruction size is so and so, and the number of registers are so and so, which means they will say one operand is being provided as the register mode. Then the number of bits required here will depend on the number of registers possible, because we are going to provide the register number as one of the inputs. Got it? And then they will ask you how many bits will be available to provide the opcode if some bits are dedicated to specify the mode. Or they will ask you how many different operations can be provided, or how many different operations are possible in this architecture. That depends on the number of bits given for the opcode. So all these questions may be possible on this mode, register mode, right? And next one is register indirect mode. So what is register indirect is, the name itself says that it is not register direct, it is register indirect, which means register will contain the address of the operand where the operand is actually present, right? So I hope you remember what an effective address is. The effective address is the address at which the operand is present, and the address we get from the instruction is the normal address. It might not be the effective address, isn't it? I already told you this, just remember it. Effective address is the address in the memory at which the operand will be present, and we do all the other things in order to compute the effective address. Got it? Now in this case, register indirect, what is given is, if you are talking about the same instruction, let us say add R1, and in case if the mode is given as register indirect mode, it means that we have to go to the register R1. Let us say this is the stack of registers, collection of registers, and let us assume that this is register R1, and now we have to go to register R1 first Assume that we went there and then we found that the number 300 is present in that register. Now in case of register addressing mode, 300 itself is the operand, but in case of register indirect addressing mode, 300 is not the operand, it is the address, and also it is the effective address, which means our operand, required operand, is present in the memory at the address 300. Therefore we have to go to the memory. Assume that this is the memory. We have to go to the address 300 and assume that there is a number 400 present there. Then this is the operand that we should get. Got it? So what is register addressing mode? Register number will be provided in the instruction. Using that, we are supposed to go to the register and then get the address. That is nothing but the effective address of the operand. Using that address, we are supposed to go to the memory and then get the operand in order to finish this execution. Got it? Therefore, if you try to see how it has to be evaluated, we are going to take the accumulator and then we have to go to the memory, and in the memory we have to go to the address that is present in the register R1 and then add it and put the result in the accumulator. This is how it is supposed to be executed. Got it? So what are the various types of questions possible on it? So what is the advantage of using this addressing mode is simple. In normal mode, if you don't want to use this register indirect, if you directly ask it for let us say, if you directly provide the address here instead of providing the register, one thing is the size of the instruction is going to be huge, right? And then the second thing is, next time if you have to refer to any word either present at the same address or present at address which is somewhat close to this, it will be difficult to again specify it, or we might have to specify the same address again and again. So whenever the same address is required many times, it is very often useful to store that address in the register and then refer to that register number instead of providing that address again and again. Got it? So therefore one advantage is that the size of the instruction is going to be reduced, but then it comes with a penalty. We have to go to the register and then we have to go to the memory, but then it has got its own advantages. We'll see it later, we'll see it in the next. Okay, so what are the various questions possible on this? Then they will ask you, if the size of the register is so and so, if the size of the register is 8 bits, then how much address can we actually refer to? With 8 bits we can refer to a size of memory which is equal to 2 power 8, which means 256 words. We can refer to any of the 256 words, isn't it? Or if it is 16, then we can refer to 64 kilowords. So that kind of questions will be possible there, right? And now what is the main advantage of it? Size of the instruction is less. Along with that we have some other flexibility as well. So what happens is, along with this register indirect mode, some of the architectures, some of the computers, they also include one special type of mode called as auto increment and auto decrement. Let us say we are having a table of data and our program needs to access all the values in this table one after the other. Assume that the first value is present at 300 and the second value is present at 301, third value is present at 302, 303, so on. You can assume it as a simple array also if you wish to, but then in generic form we call it as a table. Now assume that our program has to execute, has to access this one first, and then this one, and then this one, and then this one, and so on. Now if I have to write a program in which I have to fetch the values from these addresses in the memory, then every instruction should contain this address 300, right? And then 301 and then 302. So just to cut it short, what I'll try to do is, I'll first load this particular address 300 in the register R1. Let us say any register, just for the sake of example I'm saying R1. I'll just put it there, and then using the next mode, see this mode is over, this mode is simply accessing the memory which is present in this address, right? That is over. Now I'm talking about auto increment and auto decrement. Now this is related to register indirect itself. Some of the computers are providing a flexibility where you are going to have register indirect mode along with that we have this additional operation also possible. So what we do there is we go to the memory and access the address, this part present at 300. After accessing, either we increment or decrement, that is called as auto increment or auto decrement, right? So auto increment or auto decrement will help us in moving the address to the next word or the previous word as long as your program needs it. Got it? It will be very useful when you are trying to implement a stack. Got it? In a stack, what we do is whenever we push, we have to increment it and then do the pushing, or we have to decrementing and decrement it and do the popping. So such operations will be possible by using auto increment and auto decrement operations. Got it? So this register indirect mode, when combined with the other operations like this, will give us a new mode which is called as auto increment or auto decrement. Now incrementing and decrementing a register need not require a CPU. Think about it. If I have a register, if I want to increment the value or decrement the value, I need not go to the CPU, or I need not go to that arithmetic unit. I need not use an adder. How is it possible? Because at the core of the register, we are going to design a register as a collection of bits, right? And each bit is going to be stored using a flip-flop, right? Now we have seen that already in digital, that we can collect a sequence of flip-flops and connect them in such a way that they can be used as a counter. Therefore, a register circuit is also going to be having the connections using which it can be used even as a counter. Then what happens? If you give it a clock, we know that a counter will increase by 1. Therefore, incrementing and decrementing a register can be done easily. That is why later I'll again show you this. A register is not just going to have read write. It is also going to have increment and decrement control signals. If you see a register, it can have increment signal, it can have decrement signal, as well as it can have load signal also. Got it? So we shall see this all again when I come to the exact design of the CPUs, where we shall discuss about how the registers are designed, how they are connected. But then understand that it is very easy to implement auto increment and auto decrement, not as a part of the not without using this CPU at all, not without using our let's say arithmetic unit. Without using arithmetic unit also we can implement this. We shall come to this point again. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities or 50 lakh universities, But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.